This is another binomial situation involving having a boy versus a girl. So in this case, this is a family with 5 children, and we want to know all the possible outcomes of boys versus girls, and then the probability of having 5 girls or 4 girls, 3 girls, and so on. So I listed out all the possible outcomes here, and I want to start out by seeing how many there are in each category. So I see here that there's one way to list out 5 girls. There's 5 ways for 4 girls and 1 boy. There are 10 ways for 3 girls and 2 boys. There are also 10 ways for 2 girls and 3 boys, 5 ways for 1 girl, and only 1 way for no girls. And again, in this problem, I see this symmetry, where I can draw a line down the middle, and the numbers on the left match the numbers on the right. We see that reflective symmetry across the line. So a total number of outcomes, I see there are 32, and I can do that by adding them all up. I could also use 2 to the 5th power. Again, the 2 is because there are 2 outcomes, either a boy or a girl, and the 5th power is because there are 5 children. And 2 to the 5th power is 32, which tells me my number of outcomes, and I know that I've listed everything I need. So now, the probability that you have 5 girls is going to be 1 out of 32. The probability that you have 4 girls is 5 out of 32. The probability that you have 3 girls is 10 out of 32, but that can be simplified to 5/16. The probability that they have 2 girls is going to be the same as 3 girls at 5/16. The probability of having 1 girl is again 5/32. And the probability of having 0 girls is 1/32. Now you might be asked something a little bit more challenging. For example, what is the probability that only 2 of the children... Sorry, got interrupted. The question is, what is the probability that only 2 of the children are boys, and that the boys are born in a row? So if only 2 can be children, that's going to eliminate 5 girls, 4 girls, 3 girls and 2 boys works, but they can't have 3 boys, they can't have 4 boys, and they can't have all boys. So I'm stuck in this column only. And then I need them to be born in a row. So here they're born in a row, here they're born in a row, here they're born in a row, and here they're born in a row. For the rest of the examples, they are split apart. So the probability that only 2 of the children are boys and that they are born in a row is going to be 4 out of 32. Alright, now another example of a question that you might get is, what is the probability that they have at least 2 boys born in a row? So that changes things a little bit. I can still include this one here, where they have 2 boys in a row, 2 boys in a row, 2 boys in a row, 2 boys in a row. I can still include those 4 outcomes. But now they can have more than 2 boys born in a row. So here's 3 boys born in a row, 2 boys in a row, 2 in a row, 3 in a row, 2 in a row, 2 in a row, 3 in a row, 2 in a row, and 2 in a row. And we have 4 in a row, 3 in a row, 2 in a row, 3 in a row, 4 in a row, 5 in a row. Sorry, a little fast. But I can count up all those purple marks, and I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 ways out of 32. So the probability that they have at least 2 boys born in a row is 19/32, which is significantly larger than only 2 boys in a row.